everyone, once again welcome back to my YouTube channel. I hope you have enjoyed my previous video in which I have talked about various introductory things about the physics, and I also discussed the syllabus. If you have not watched the video yet, then here is the link above. Just click on this link and go back to the previous video, find out that video, check it out, and then come back to this video again. This video is going to be important to build the basics, and therefore let us start with Unit 1 Physical World and Measurement Lecture 2. Today I would like to talk about how physics is related to technology. So there are various advances which are happening nowadays. All these advances are possible just because of various experiments and studies which are being carried out in physics. First of all, I have written the point, that is development of conveyance system, that is we are having steam engines, diesel engines, petrol engines, and rocket engines, etc. So all these engines work on the principles of physics. Because we have developed, we have studied such kind of systems, that how we can convert one form of energy into the other form. Therefore we are able to implement them practically, and hence the commuting system is growing day after day. Nowadays we are planning to launch the humanless cars, that is driverless cars, and which will be driven by the robots only or computers only. So this possibility is happening just because of advances which are being carried out in physics. Then we are having a well developed communication system in terms of telephones, in terms of television and radio, because we have studied various sound waves, and we have also studied that how we can send these waves from one point to the other point, and hence we are having a well developed communication system, and we are able to communicate internationally, and nowadays we are globally connected, and this is all possible just because of various advances and studies which are being carried out in physics. Then we are having well developed weather forecasting system of each and every country. It happened just because of launching of satellites. We launch various satellites which are geostationary, and these satellites help us to forecast weather. Nowadays we can already predict what kind of climatic conditions will be there, whether the day will be sunnier one or it will be the hotter one, or it is going to rain today or not. We can check all these conditions beforehand, and this is possible just because of various advances which physicists have carried out, and which they have talked about and researched about. We are nowadays also exploring the space. So space exploration is possible just because of physics. We are sending spaceships to study the various planets, to study the various to study the Milky Way galaxy and the various objects in the Milky Way galaxy or in our solar system. So this space exploration is possible just because of advances in physics. We can send the spaceships with man and without man. So manned and unmanned spaceships are being sent to the space for the exploration of space. Then we are having a more industrial advancement. We are installing new machines day after day which are more productive, and they just ensure a high quality. So every kind of industrial development is possible just because of physics. As I said, that the working of machines is possible just because of advances which are happening in the physics. So hence we can say that physics helps us to grow the technology in a better way. Then we are having a food preservation facility nowadays. Earlier it was very difficult to store the food, but nowadays we can preserve food for a longer duration, like creating vacuum while packing the food in the cans, and also we can store food in the cold storages or in the refrigerators. And again, refrigerator is based on the laws of physics. Therefore working of refrigerator and cold storages helps us to develop the technology so that we can preserve the food for the longer duration. So we can see from here that how physics is related to technology. We cannot grow in terms of technology if we are not making the advances in physics. Then we are having a physics in relation to various other subjects. So let us see how physics is related to mathematics. So as I have written the first point, it's a relation to mathematics. We all know that mathematics is a language of physics. Therefore, in order to understand the physics, we have to understand mathematics. Therefore, I can say that mathematics is directly linked with physics. So I want to tell you that great mathematicians were the great physicists in history. So mathematics is directly related to physics. We cannot study physics without knowing the mathematics, so it has a direct relation. Then physics is related to chemistry. How it is related to chemistry? We are having a modern periodic table. I definitely know that you have learned modern periodic table, and the elements which are arranged in modern periodic table, it became possible just because of various experiments which happened in physics. In physics, we are having a different subject that is called nuclear physics. It helps us to study about the various nuclear reactions like fission and fusion, which we study in chemistry as well. So physics helped us to grow chemistry and to provide a modern periodic table, which is really a great advancement. Then physics is related to biology. So question arises, how physics is related to biology? And the answer to this question is that we use various tools in the field of medical. If we have to treat ourselves with the laser technology, then laser is advancement in physics. Therefore, physics help us or it helps doctors to provide various tools so that they can carry out various operations. Also, x-ray facility is available to doctors, and it is possible just because of advancement in physics, and therefore physics is helping tool for biology. Similarly, nowadays people go for MRIs, which is based on the magnetic effects, that is magnetic resonance. So again, this is all advancement in physics which helped to grow biology, and nowadays people are able to carry out painless surgeries just because of physics, and hence biology is linked with physics. Then there is astronomy, that is again a science of study about the space and the objects which are related to space. We can just grow about the space exploration, as I talked about it earlier, that we can know more about the space or astronomy by advancing in physics. So astronomy is a kind of branch which is related to physics only, but still it is regarded as a separate branch, and it is directly linked with the physics. Then physics has a relation with geology as well, not geography, it is geology, because geology means study of Earth's surface. So geo means earth and logy means study. So geology is a study of earth. So we can only study earth with advances in physics. So physics is directly related to geology, which we called geography as well. So we can see that how physics is connected to various other sciences. That means advances in other sciences is not possible if physics will not provide its helping hand to the other branches. So let us move forward, and we will talk about the various basic terms which we need to know before developing various factors and various other things in the subject. So we are going to talk about physical quantities a lot. I need to define what the physical quantities are. Physical quantities are the quantities which describes laws of physics, and these physical quantities are important in order to learn about the various things associated in physics. For example, we are having force. Force is a physical quantity because we always define it in various terms. Similarly, mass, whenever we have to study various things, various phenomena, we have to describe the laws of physics. We have to talk about mass as well. So Physical quantities are those quantities without which we cannot define the laws of physics. Then a quantity is completely specified if it has, when we call a quantity as a physical quantity, so there are certain conditions that when will we regard a quantity as a physical quantity. So if we will regard a quantity as a physical quantity if it has magnitude only, or it has numerical value only. So first point is if it has numerical value only. So if there is some quantity and it is having only numerical value, it is not having any units, it is not having any direction, it is just a pure mathematical number, then it is a physical quantity. For example, we are having relative density. So relative density is the ratio of density of a substance to the relative of to the density of water. Sorry, it is a ratio of density of substance to the density of water at 4 degrees Celsius. So relative density is a pure number because units are going to cancel out, but this pure number is telling us how density of one substance is related to density of water at 4 degrees Celsius. Then again we studied about refractive index in class 10th, that is ratio of sine of angle of incidence to the ratio to the sine of angle of refraction. So again it is a pure number, but it is describing that how light will change its speed when it will enter from one medium to the other medium. So this number is telling us how light is going to change its speed. So this is a pure number, but is telling us and is providing us some information about the speed of light when it moves from one medium to the other medium. Similarly, relative density is telling us how the densities of two different media is related. So when these pure numbers are giving us information about something, that means these numbers are regarded as the physical quantities. Then we can say that a quantity is a physical quantity if it has magnitude only. By magnitude I mean a scalar quantity, that is which has a numerical value and has some unit like mass. We can say 5 kg. If a sugar is present 5 kg, we are having a sugar 5 kg, that means it is having a mass and it is having a unit, then it becomes a physical quantity. Similarly, length, that is it could be defined as that the distance between 2 points, initial point and the final point. So this distance is called a length, like 5 meter. It is having a numerical value as well as it is having unit, so it becomes a physical quantity. Similarly, we can say a quantity is a physical quantity if it has magnitude, it has direction, and such physical quantity is displacement. Like we have been displaced 5 kilometers towards north in 5 minutes. So 5 kilometer displacement in north direction means displacement. It is having a direction, it is having a numerical value along with the unit. Then velocity, I am moving with the velocity of 5 kilometer per hour in southeast direction. So again it is having a magnitude and a direction, so it is again a physical quantity. Then in this lecture we are again going to talk about some more basic terms, that is need for measurement. Why do we need to measure? As the name of the unit is physical world and measurement, so we have talked about this physical world and we have understood some of the factors. Now I am going to talk about what is the need of measurement. If we want to know particularly about any phenomena, if we want to find the accurate results, for accuracy we have to take the measurements. Let us take one example. Let us say you just want to go to tailor and you just want a suit to be stitched for yourself. If you want to get your dress stitched, and if tailor is not having a measuring tape and tailor is measuring all the measurements, he is taking all the measurements with his hand only, with the help of his palm only, so then definitely you are not going to relying on that tailor, because he is not having a measuring tape, and you do not rely on that tailor because he might change the measure, right? So in this way, if we want accuracy, if we want to understand the phenomena deeply, then we need to calculate the things. Similarly, if we want to study how many hours are there in a day we have to calculate accurately about the rotation to be completed by the earth in what time. So we need the measurements to define various physical phenomena, and hence there arises a need of measurement. Then next topic is about units for measurements. I am not going into very deep detail with all these topics because these are fundamental topics and these topics can be covered at home as well, but as you need some basic lectures, so I am trying that you should have some basic idea and you can easily understand the various factors. So let us talk about units for measurement. So in order to measure a physical quantity, unit is chosen. Without choosing a unit, we cannot measure any physical quantity. Let us say you just want to buy 2 kg apples from the fruit vendor. If a fruit vendor is not having a unit, if he is not having a stone on which 2 kg is written, you are not going to purchase the apples, or you are going to doubt the fruit vendor whether he has measured accurately or not. So in order to measure a physical quantity, we need a unit, or a unit is chosen and is compared with the given physical quantity. So as I have taken an example of a fruit vendor, what fruit vendors do, they just keep a 2 kg stone where it is marked with the help of machines that 2 kg. That fruit vendor put the stone on one side of the weighing machine, and in the other side of the weighing machine he put 2 kg apples. When the balance is reached at the same point, at that time he says that these apples are 2 kgs, and you also believe to the vendor. But what if he has used a stone, a brick? Then in that case you do not rely on the vendor, you always doubt him, you always try to look for the other option, whether he has measured he has measured apples accurately or not. So the thing is, the standard unit is chosen. Also fruit vendor is going to choose a 2 kg weight instead of choosing a vessel which measures 2 liters. So different physical quantities are measured with the different units. We cannot measure the apples with the measuring tape, we can only measure the apples with the weights. We can only measure the liquid with the help of vessel where liters are marked. So different quantities are measured with the help of different units. So the number of times unit contained in physical quantity represents the numerical value of physical quantity. Let us say a fruit vendor is having only one stone, but you want to purchase 5 kg apples. So the fruit vendor is going to, what fruit vendor is going to do, he has taken 5 polythene bags and he has put 1 kg apples in one bag, then put the weight on one side of the balance, and on the other side of the balance he has placed some apples. So when the balance is at the same point, then he will say that this is 1 kg apple. He will just pick up the other polythene and will put the other 1 kg apples in that. Now when the balance is at the right place, then he will say now these are 2 kg apples, 2 envelopes means 2 kg apples. Then similarly so on, he will do these measurements 5 times. That means in order to sell his 5 kg apples, fruit vendor will have to measure the quantity 5 times, so that he could measure 5 kg apples accurately, because he is not having any other stone with him, he is not having any other weight with him. He can only measure 5 kg apples by measuring 1 kg apples again and again. Now he has measured the apples 5 times. So therefore number of times he has measured 5 multiplied by unit, that is kg. So 5 kg are the apples. That means physical quantity is equal to the number of times measurement has been taken multiplied by the unit. So I have written that if x is the physical quantity, x could be your apples, x could be your sugar, and it could be any other physical quantity. So x is a physical quantity and is representing number of times a vendor is measuring it, and u is the unit which is chosen. So I can say x is equal to nu. That is, if apples is equal to 5 kg, you can imagine it like this as well. So if we are having two different units, like you do not want to buy the sugar in terms of kilograms, you can also buy the sugar in terms of grams. Now you can say if first time you have purchased the sugar in terms of kilograms, then let us say x is the physical quantity, sugar x is equal to physical quantity. Then n is number of times the sugar is made, like 5 times you wanted sugar, so 5 kilogram, because kilogram was the unit chosen. Now we have the other units, that is grams. The other time you went to the market, you have chosen the other unit x, and but you still want to buy a sugar. Now you have chosen a unit gram. That means we know 1 kilogram is equal to 1000 grams. Now if a vendor is going to measure with the gram stone, then he has to measure 1000 grams 5000 times in order to give you 5 kg sugar. That means again you are going to buy 5 kg sugar, but now you are using the unit grams. Therefore the shopkeeper is going to measure it 5000 times. So 5000 into gram will become 5000 gram. That means physical quantity is same this time as well. So we can say n1 u1 is equal to n2 u2, that is 5 kg is equal to 5000 grams. That means I can say nu is equal to constant. Earlier it was 5 kg sugar, again second time it is 5 kg sugar. That means again the quantity is same, although it is measured with the different units. But if unit is bigger, then the number of times we have to measure the quantity decreases. But if unit is smaller, then number of times we have to find or measure the quantity increases. So smaller is the unit, greater is the numerical value, and greater is the unit, smaller is the numerical value. So that is why I can say that nu is equal to constant, or from here we can say n is inversely proportional to u. Inversely proportional means for the larger unit, number of times we have to carry out the measurement is small, and smaller is the unit, number of times we have to carry out the measurement is large. So we have just developed how unit and number of times we have to make the measurements are related. Choose the bigger units if you want to decrease the number of times you have to measure the quantity, or choose the smaller units if you want to increase the number of times you have to measure the quantity. So there are two basic types of physical quantities, that is fundamental quantities and derived quantities. Fundamental quantities are the basic quantities, and these cannot be subdivided into various other parts. There are 7 physical quantities in physics and 2 supplementary fundamental quantities. These 7 physical fundamental quantities are mass, length and time, and mass, length and time are belonging to mechanics. Apart from mass, length and time, we are having other 4 quantities, that is electric current, luminous intensity, temperature and quantity of matter contained in a body. So all these 7 quantities are fundamental physical quantities. Apart from this, we are having 2 physical quantities which are supplementary, that is plane angle and solid angle. This is all about the fundamental quantities, and the other type of quantities we are having is derived quantities, which are driven from the fundamental quantities, basic quantities. That means we can split these quantities or express these quantities in terms of fundamental quantities or basic quantities. So these quantities contain force, velocity, acceleration, work, power, energy and many other physical quantities. That means all those physical quantities which can be expressed in terms of fundamental quantities are called derived quantities. So this is all about today's lecture. I hope you have understood all the basics, and in the next lecture we will be talking in more detail about the physics. I hope you have enjoyed this thing, and feel free to take your notes, pause the video in between and take your notes, and also press the like, subscribe and share button so that you should not miss out my videos.